Hello everyone. In the context of the 16th International Conference on Information Assurance and Security 2020, we have the pleasure to present our work about preventing DDoS attacks in the cloud, titled Towards a Proactive System of DDoS Attacks Detection in the Cloud. We begin with a brief introduction and then we define the problematic. After we detail our proposed approach, in the next we show the conducted experiments, results and discussion. Finally, we end with main conclusion. In this slide, we define the cloud computing system. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet, as defined by Microsoft. This figure presents the growth of volume of the traffic between 2015 and 2020. The traffic is growing dramatically in this duration. Characteristic of cloud computing: on-demand self-service. Service can be provided without human intervention on the provider side. Broad network access. Cloud capabilities are available over the network and accessed by heterogeneous clients such as mobile phone, laptop. Multi-tenancy and resource pooling. The provider's computing resources are pooled together to serve multiple customers. Rapid elasticity and scalability. Capabilities can be elastically provisioned and released in some cases automatically to scale rapidly outward and inward proportional with demand. Measured service. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumers of the utilized service. In this figure, we present the general architecture of cloud system. The first layer, named as physical, this system serves infrastructure as a service. For example, Amazon, Google, FlexiCloud. The next layer, platform as a service. For example, Microsoft Azure, Google App Engine, Amazon SimpleDB S3. The last layer, software as a service. For example, Google Apps, Facebook, YouTube, Salesforce. Therefore, cloud computing has many challenges. The security issues is the measure as shown is figure. In this slide, we define DDoS attacks is the major attacks threat the cloud system. Distributed denial of service attack is a type of attacks that aims to make services or resources unavailable for indefinite amount of time by flooding it with useless traffic. We show in the figure the attacker control many devices over a network to attack a server by overwhelming it with a huge number of packets. We can divide the impact of DDoS attacks in the cloud into direct impacts, for example, service downtime, economic losses due to downtime, business and revenue losses, disruption to dependent services, and direct impact, for example, economic losses due to resources, energy consumption costs, attack mitigation costs, collateral damages to others. Our purpose is developing a proactive detection system of DDoS attacks in the cloud. Our system is performed with 4 major steps. The first step, forecast number of normal flows in the next minute. The second step, count number of received flows. Third steps, pre-process suspected network flows. And last step, Classification into DDoS or normal flow. Forecast number of normal flows in the next minute. In this step, we used time series analysis based on statistical methods and deep learning to forecast number of normal flows in the next minute. Count number of received flows. Here, the system count number of received flows. If the number is far exceeded the forecasted number, the system launches steps 3. Pre-process suspected network flows. This step aims to cleaning and normalizing the data.
Step DDoS attacks detection. In this step, the system classifies data traffic network into DDoS attacks or normal. For this purpose, 6 machine learning classifiers are used to choose the best model. The experiments aim to show the effect of using time series analysis for a proactive protection against DDoS attacks in the cloud. To evaluate our system, we used public dataset CADDS001. First, we prepare data to forecast 10 steps by counting number of normal and DDoS attacks in each time window of 60 seconds. This figure presents the number of DDoS attacks in each minute, and this figure presents the number of normal flow in each minute. That minute contains DDoS attacks characterized with a huge number of flow compared to other minutes. In the next, we compare ARIMA, LSTM, and CNN for forecasting. This table presents the result of different used methods for forecasting. We notice that LSTM has the best results, an MSE of 4.84 and MAE of 1.84, followed by CNN MSE of 4.89 and MAE of 1.84. However, ARIMA has a good result, a MSE of 5.49 and MAE of 1.96. This figure shows the results of ARIMA in the forecasting. This part presents the training data, and this part presents the testing data, including predicted value plotted with the red curve. The same for CNN and LSTM in the next slides. And the next, we present the result of classification step. We tested 6 machine learning algorithms: logistic regression, decision tree, random forest, gradient boosting, multi-layer perception, and naive Bayes classifier. We noticed that decision tree and random forest obtain a best results, an accuracy of 100% and an F1 score of 99%. But it's preferable to use decision tree due to lower time detection. Gradient boosting and MLP are also obtain good results. Logistic regression and naive Bayes classifier aren't good to use for our case. In this figure, we present ROC curve of DT model. In this table, we compare our method with recent previous method. We find that our system reached the best result in the term of accuracy and F1 score. Conclusion: our system consists of 4 steps. The first step forecasts number of normal flow in the next minute, count number of received flows in the current minute, pre-process of suspected flows, classification into DDoS and normal. LSTM and CNN reach the best results for forecasting. Decision tree and random forest catch a good results in the classification step. Thank you for your attention. Don't hesitate to contact us. Thank you.